Okay, everyone, let's begin then. So we started, in fact, we completed all the concepts of differential equations in the last session. So it's mostly integration. So if you know integration well, differential equations is not really that difficult because it has the same concepts with just a couple of additions, couple of additional steps that you have to follow. So what is a differential equation? It's any equation that has a dy over dx term in it, right? Any equation that has dy over dx term, we call that a differential equation. How do you solve the differential equation? Solving differential equation basically means finding an equation that connects x and y without the dy over dx term. So if you have an equation like this, we want to eliminate dy over dx from there and find an equation that only has y and x in it. What's the process for that? The first thing that we always do is we separate the variables. Okay. We separate the variables such that on one side you have dx, and then on the other side you have dy, both of them in the numerator. And then the side that has dx, you should have x on that side, all the x terms on that side, and the side that has dy, you should have all the y terms on that side, right? That's for x and y. If you have any other variables, it works the same way for those other variables as well. You want one variable on one side and the other variable on the other side. And then you just integrate both sides. You have plus c on one side. You just put that on any one of the two sides. You use the given information in the question to find the value of c. And then eventually you make whatever variable they want as the subject in the question. And that's it. That's your solution to the differential equation. When you have your answer, when you have an equation in terms of c, that is known as a general solution of the equation. So sometimes they will ask you to find general solution. All that means is just separate the variables, integrate, and then you would have something in terms of c. Just leave it like that. That's the general solution. When you find the value of c using the given information in the question, for example, in this case, they gave us that y is equal to 2 when x is equal to 4. So you input those values of x and y in that equation to find the value of c. Once you have found the value of c, the final result that you get, that's called a particular solution. Okay, so general solution is where the value of c is unknown. A particular solution is when you have found the value of c. That's how you solve differential equation. Then you will see questions in which they ask you, after solving a differential equation, what happens to a variable when another variable becomes very large or very small. Very large means what happens to the variable when it goes towards infinity. And what happens, very small means what happens to the equation when the variable becomes almost zero, right? We looked at those examples. And then there was another type of problem where they say, explain why one variable increases as the other increases. What that means is explain why both the variables are directly proportional, right? If one increases and the other also increases, that means they are directly proportional. If two variables are directly proportional, what that means is their derivative should be positive, right? Because if they're going in the same direction, if one variable increases and the other also increases, the curve is going to look something like this. It will be going in the upwards direction. If the curve is going in the upwards direction, that means that the gradient would be positive. So in such problems, all you have to do is show that the derivative is positive, right? So in this case, we did that for this question number 13. And then finally, we learned how to form differential equations given some information in the question. For that, you need to understand some standard statements. For example, if they say rate of change of one variable is directly proportional to something, you say rate of change of y, that's dy over dt, directly proportional to x squared, that means it's equal to k times x squared, right? Similarly for inversely proportional, and what happens when you have rate of decrease, you put a negative sign there. If you have a rate of inflow and a rate of outflow at the same time, if something is increasing and also decreasing at the same time, we said the equation would become like this. It will be the rate of change equal to the rate of inflow minus the rate of outflow. We looked at this example yesterday as well. And then we looked at a few questions on this where we had to form differential equations. This was question number 1, which was relatively straightforward. But then we looked at another one which was more complicated because the information that was given in the question was related to the volume, rate of change of volume. And what they wanted us to prove was the rate of change of height. Sometimes this is what happens as well. In the question, they will give you information about one variable. So for example, in this case, they gave us information about the rate of change of volume in this statement. And then they wanted us to prove something for the rate of change of height. How do you go from rate of change of volume to rate of change of height? You use chain rule for that. That's also something that you have to do sometimes. When you have information given in the question regarding one variable and the differential equation that you have to form is in terms of another variable, what do you do in that case? You use chain rule as well, right? That's what we did in the last session. This is pretty much all that you need to know about differential equations. Apart from this, it's all the same integration rules that we've done in the previous topic, right? So if you know your integration well, this should not be a very difficult question generally, okay? But the prerequisite is that you need to remember all of those different rules that we did in integration. If you remember all of them, then this would be not a very difficult question. Now, today, what we want to do is in the next hour or so, hour and a half, or maybe 1 hour and 20 minutes, we will be doing past paper questions on differential equations. You will let me know the problems that you have from any of the 2 worksheets or from any other recent paper, and we will discuss those questions. Yes, let me know the question numbers, the questions that you have. I don't see many in the chat yet. How many are done with at least 10 questions from the worksheets? Can I raise of hands? Those of you are done with at least 10 questions from the worksheets. Okay, so I don't see many hands raised, unfortunately. Okay, so now we have more. All right, so you guys have any problems from the worksheet? The others as well, please make sure that you're practicing. That's extremely important. Otherwise, you will tend to forget stuff. Okay, Chen, let's start with this first one that I've got here. Question number 10 from the recent worksheet. Okay, so let me open that one. Okay, question number 10 from this. Let's begin with this. Okay, so this is from March 21. Paper 3-2, question number 4. This is from the second worksheet. Question number 10 from this. Let's start with this one. In the meantime, I would appreciate if the rest of you can also let me know the problems that we have, that you have. Let's start with this one now. The variables x and y, they satisfy the differential equation, this differential equation. It's given that y is equal to 4 when x is equal to pi. Solve this differential equation, obtaining an expression for y in terms of x. Okay, so now how do we think about this? The first thing that we have to do is we have to separate the variables. Okay, that's what we always do when solving differential equations. Let's separate the variables. Now, how do you think about that? First, take dx to the other side. And that will make it easier for you to think of what to do in the next step. You have 1 minus cos x dy. Just take dx to the other side first. And that gives you y sine x dx. Now what you want is you have dy on the left side and you have dx on the right side. You want all the y terms on the left side, all the x terms on the right side. This is y, you can take that to the left side. 1 minus cos x, you can take this whole thing to the right side. And that would make it 1 over y dy. And on the other side, you have sine x over 1 minus cos of x dx. The variables are separated. We have y terms on the left side, x terms on the right side. Now we can integrate both sides. It doesn't look that difficult, by the way, but let's do it. 1 over y. What's the integration of 1 over y? This is ln y, right? That's what we have on the left side. What about the right-hand side? It's a fraction. What fraction rule can we use here? What fraction rule can we use? ln rule, tan inverse, partial fractions. We had a bunch of those rules. ln rule can be used, right? What's the derivative of the denominator? Derivative of 1 is 0. Derivative of cos, so we have minus cos, right? Derivative of cos is minus sine, so that's minus into minus sine x, and that is sine x. So we already have that form. Numerator is the derivative of the denominator. We don't have to change anything in this. This directly integrates to ln of 1 minus cos of x plus c. All right. So we have integrated this now. Can we find the value of c? We have this information given. We have y is equal to 4 when x is equal to pi. Let's input those values here. Put x equals pi and y equal to 4 in this. What do we get? We get ln of 4 that equals ln of 1 minus cos pi plus c. Okay, now keep it in exact form. Do not use decimals. We avoid using decimals as much as possible inside equations. So we will not use decimals here. We will keep it in ln form. So it's ln 4 that equals ln of 1 minus cos of pi. What's cos of pi? Cos pi is minus 1, right? Yeah, cos pi is minus 1. And that leaves you with ln 4 equals ln 2 plus c, and c equals ln 4 minus ln 2. You can simplify this further if you want, although it's not necessary at this point, but if you want to do it, ln 4 minus ln 2. This is subtraction outside log, right? Inside log, it can become division. So you can write this as ln of 4 over 2. So that simplifies to just ln 2. C equals ln of 2. This is the value of c that we have now. Let's put that back here in that equation. And that would give us ln y equals ln of 1 minus cos of x plus c. C is ln 2. Now we've got the value of c as well. All right. Now we look at the question statement again. What do they expect from us? They want us to have y in terms of x. So we want to make y the subject in this equation. Now, first of all, we have log in every single term in this. Can we just eliminate log from here? We can try doing that by having a single log on both sides. So right now, on the left side, we have ln of y. On the right side, if I use multiplication log, because this is addition outside log, outside the logs, we have plus sign. So we can write this as ln of 1 minus cos of x times 2. We can write it as a single log term like this. Now we have single log in both sides. That means y equals, we can get rid of the logs, right? So y equals 2 into 1 minus cos x. That's 2 minus 2 cos x. That's what we were looking for. That's the first part. This is y in terms of x. Is this all right? Any problems with this? Any problems with this? Okay. All right, so that was the first part, fairly straightforward. Now the second part, they say sketch the graph of y against x for x between 0 and 2 pi. That's fairly straightforward. We will do the sketching part more in iteration when we have done iteration in the next class, because all the sketching we will be doing all of that in iteration, inshallah. But we can do that here as well. How do you sketch this graph? This is actually something that you do in paper 1 as well. This is just the cos graph. The easiest way of doing this is just put this in the table function on your calculator. This is y-axis, this is x-axis. We need to draw the graph from 0 to 2 pi. So we start at 0, end at 2 pi. Let's break it down. You have pi here, you have pi over 2, and then pi over 2 times 3, that's 3 pi over 2. Let's make a table on our calculator. Make sure your calculator is in radian mode. Go to the table function, put this function there, 2 minus 2 times cos of x. Start at 0, end at 2 pi. And then the step should be sufficient so that you have 4 or 5 values, right? So in this case, if I want values at an interval of pi over 2, I can use a step of pi over 2. Right, the interval, the gap between the values, that's going to be pi over 2. Let's input that here. And we've got this nice table. We can plot these values. At 0, we've got 0. That's the first value. And then at pi over 2, we have 2. What's the maximum value on this? 4, minimum is 0. Okay, so on the vertical axis, we have to go up to 4 on the upper side. What I'll do for that is I'll just extend this a little. Oops. This is weird. Okay, so this is the y-axis, and we've got 2, 4 like this. Let's mark these points. At 0, we have 0. At pi over 2, we've got 2. And then at pi, we have 4. And then 2 again. And then finally, you've got 0. What is the graph going to look like? Now, you should remember the shape of the cos graph. This is the standard shape of the cos graph. And if it's a reflection, then it just gets flipped and looks like this. So this is a reflection because of this negative sign. So what is the graph going to look like? This is the shape of the graph. If you don't remember the shape, then you would have to take more points. So it's important that you remember the shape so that just sketching a few points, you can join those points using the correct curve. This is what it is going to look like. That's your graph for y equals 2 minus 2 cos x. All right, that was the second part of this. And that's it. Let's move on to the next one. Next question. Yes. Okay, question number 8 from the worksheet. Let's have a look at this now. Question number 8. Okay, so this looks like a good one. Question 8 from the worksheet. Let's try this. All right. It says the number of insects in a population T days after the start of observations is denoted by N. The variation in the number of insects is modeled by a differential equation of this form, where k is a constant and n is taken to be a continuous variable. It's given that n equals 125 when t is equal to 0. Ibrahim, yes, I can. Now I can. Okay, Ibrahim, let's talk about that. Let's talk about that after Yeah, you might have been sending messages in the wrong chat. Okay, so if you're sending messages, either send them to everyone or send them to the host account. Okay, otherwise I might not be able to see them. Either send them to the host account, not the co-host one, or just send them to everyone. All right, let's have a look at this. It says solve this differential equation, obtaining a relation between n, k, and t. How do we solve this differential equation? Let's look at this. K is a constant. N is taken to be a continuous variable. What does that mean? Continuous variable means something that can have decimal values. Okay. Now, even though N represents the number of insects, that's supposed to be an integer. But in order to make a differential equation, we assume that to be continuous, because if it's not continuous, differentiation actually does not work. So that's why this assumption is important. But they've given that. It's not something that you need to worry about. How do you solve this differential equation now? Obtaining a relation between n, k, and d. Let's try this. dn over dt. That's the differential equation. dn over dt. That is equal to kn cos of 0.02 times t. Now, how do you start? The first step is always separating the variables. Okay. How do you separate the variables? You take dt to the other side. Let's do that. So you have dt on the right side. Now you want all t terms on the right side, all n terms on the left side. This is n. You can bring that to the left side. So you have 1 over n there. K is just a constant. It's your choice. If you want to leave that on the right side or bring that to the left side, it does not matter. We can keep that in the right side as it is, and that's okay. Into cos of 0.02 times t. Variables are separated now. We can just integrate both sides separately. Let's integrate the left-hand side and the right-hand side. What's the integration of 1 over n with respect to n? That's just log of n, right? N of n. On the right side, we have k, that's the constant that remains as it is. What's the integration of cos? Integration of cos is sine. So this becomes sine of 0.02t divided by the derivative of this thing, which is 0.02 plus c. So the integration part is done. Now we need to find n, some relation between n, k, and t. Okay. Now we have n, we've got k, and we've got t, but we also have c here. So we want to get rid of c somehow. We want to find the value of c. How do we do that? We have this information. We have this point given. They've told us that n is equal to 125 when t is equal to 0. Okay. Now, what can we do for this? We can just input that point. That is n equal to 125 and t equals 0. Let's input that here. And that gives us ln of 125 equals k into sine of 0.02 times 0, that's a 0, divided by 0.02 plus c. Sine 0 is 0, that will make this whole thing 0. And you're left with c equal to ln of 125. All right, that's the value of c that we have. Now we can input that back in that equation. And that equation now becomes ln of n, that equals k sine of 0.02t divided by 0.02. By the way, if I want to bring this in the numerator, I can do that. How would that work? 0.02 is in the denominator right now, right? We can simplify this. 1 over 0.02, right? What's that? That's 50. So I can write this as 50k into sine of 0.02t, right? So I've simplified this. 1 over 0.02, that's 50. I can write 50 instead of this in the numerator, plus c, which is ln of 125. This is what we wanted to do. We wanted a relation between n, k, and t, but we cannot leave it like this. I told you about this general rule earlier as well. Even if they've not specified anything in the question, you always want one single log term in the final answer. If you have multiple log terms in the final result, it's necessary that you always convert them to a single log term. Okay, you cannot leave it like this because you've got one log term here, another log term here. You cannot leave it as the final answer. In most cases, marking scheme would have one out of these 5 marks for converting that to a single log term. So you cannot leave it like this. How do you convert it to a single log term now? We can bring this log term to the left side as well, so that it becomes ln of n minus ln of 125. That equals 50k times sine of 0.02t. Now this is minus outside log. Inside log, it will become division. So I can write this as ln of n divided by 125. That equals 50k sine of 0.02 times t. And this is fine. I can leave it like this. They did not want a specific they did not want a specific variable to be the subject in this case. We just wanted some relation between n, k, and t. This is fine. You can just leave it like this, and that's perfectly okay. All right. If you want, you can make n the subject as well, but it's not necessary. All right. So this would be a final answer for the first part. Now let's look at the second part after this. It says, given also that n is equal to this, when t is equal to 30, find the value of k. Now this is fairly straightforward. We can input these values of n and t to find the value of k. N is 166 and t is 30. Let's put that here. N equal to 166 and t equal to 30. This gives me ln of 166 divided by 125. That equals 50k into sine of 0.02 times 30. Okay. Now, since we're looking for the value of k now, they've not specified that they want an exact answer or anything. So we can convert this to decimals, and that's perfectly okay in this case because we're just finding the value of a constant. What would that be? On the left side, I have ln of 166 divided by 125. Just use a lot of decimal places because this is not your final answer yet. So you can write 0.283674. On the right side, you have 50k into sine of this. Okay, now what is sine of this? Make sure your calculator is in radian mode. Sine of 0.02 times 30. On the right side, I have 0.56464. Okay, now what's the value of k that we get from this? This times 50. And then on the other side, we had 0.283674. Divide that with this answer. And that gives me k equal to 0.010048. To 3 significant figures, that would be 0.0100. Okay, so even 0.01 is fine. This is your final result. This is the value of k that we were looking for. That's the second part. Okay, so in this case, you just had to use a calculator to find the value of k, and that's your final answer. Okay, that was part 2. Yes, Ibrahim, in the previous part, you could also convert it to e power something, and that's also okay. You want some relation between n, k, and t. Okay, it could be any relation. It doesn't matter. You can write this as n over 125 equal to e raised to the power 50k into sine of 0.02t, and then multiply 125 on the right side, and that's also okay. That will also be acceptable. It's equivalent form. Okay, it's an equivalent form, so that will also work. All right, now let's look at the last part. Now in the last part, they're actually asking us now to obtain an expression for n in terms of t, and then find the least value of n predicted by this model. Okay, now how do we think about this? First of all, they want us to write n in terms of t. Okay, let's do that. From the first part, we have this equation, ln of n over 125, that equals 50k. Now we've got the value of k as well. We can use that 50 into 0.01 times sine of 0.02 times t. So that's the equation that we have from the first part. Okay, so we can input the value of k there. Now, how do we make n the subject? The base of ln is e. We can take e to the other side, make it the base of this number. 50 into 0.01, that would be 0.1 and then 0.5. So this is going to become n over 125 equals e raised to the power 0.5 into sine of 0.02 times t. So this e goes to the other side, becomes the base of this whole thing. And this is n over 125 equal to this. Now I'll just confirm. Yeah, so that's 0.5. Now let's take 125 to the other side, and that gives us n equal to 125 times e raised to the power 0.5 into sine of 0.02 times t. That is n in terms of t. That's one thing that they wanted us to do in this part. So we are done with that. This is n in terms of t. Now, based on this, what they want us to do is, they want us to find the least value of n predicted by this model. Least value of something, minimum value of something. How do you find minimum value of a variable, maximum value of a variable? Generally, what we do for that is, we find the derivative and put that equal to 0. That is one idea that we could use here. What's the derivative? dn over dt. We've got the derivative in that question itself. You could try inputting this equal to 0. You would get 0 equal to something. 0 equal to cos of 0.02t, because k and n, they will both become 0. Let me actually write that in full form first. 0 equals kn into cos of 0.02t. And then that becomes 0 equals cos of 0.02t. Find the value of t from this. Whatever value of t you get from that, you would input that here to find the least possible value of t. But the problem with that is you're looking for the least value. Now, if you just find a value of t here, at that particular value, n could be maximum or minimum, right? We would just get the turning point. Now that turning point could be maximum, it could be minimum. So we would also have to check the second derivative to see if that value is a minimum or a maximum, right? Okay, let me repeat this. They want us to find the least value of n predicted by this model. Minimum value of n. So there is a variable n. We want the minimum value of that. How do you find minimum value or maximum value of anything? You put the derivative equal to 0. That's one idea. That you put dn over dt equal to 0. Right? That's what you generally do for that. You could try doing that here. You would put the derivative equal to 0. And that will give you some value of t. In fact, you can get multiple values of t from here. But the problem with this method would be, you would also have to find the second derivative to see if that turning point is a maximum or a minimum. So that will you will need to find the second derivative here, input those values of t that you're getting, and see what value of t is going to give you a minimum rather than a maximum. That's one idea. You can do that. It works, but it's going to be fairly long. This is just a 3-mark question. And in those 3 marks, you have already made and the subject as well. So this least value would maximum be 2 marks, if not 1. So we need to do something more efficient than this. We have found n in terms of t here, right? We found n in terms of t. What we're looking for is the least value of this variable. Now look at the expression on the right side. What can change in this expression? What's the variable in this expression? 125 is a constant, that's not changing. E is a constant, that's not changing. 0.5 is a constant, that's not changing. The only unknown is t, right? That's the only variable that we have. Only t can change here. Now, t is inside sine, right? We have sine of 0.02 times t. Now, do we know the maximum and minimum possible values of the sine function? There's no restriction on t here, right? T could be anything. Now, if t can be any value, what are the maximum and minimum possible values of the sine function? Sine of 0.02t, it has to be between -1 and +1. It can't go outside this interval, right? So if you're looking for the least value of this whole expression, the quickest way of doing this would be that you just input the least possible value of sine in this expression. So what we can do is, we can say, let's input sine of 0.02t. Let's put this equal to -1, because that's the least possible value this thing can have. Okay. When the sine function is at its minimum value, this whole thing would also be minimum. So that's what we can do here. We can say, let's input -1 in place of that. That will give us the least possible value of n. And that becomes 125 into e raised to power 0.5 times -1. You can put this on your calculator and see what that gives you. 125 into e raised to power minus 0.5, and that is 75.8. Since we are talking about number of insects that is supposed to be an integer, we can round it off to 76. This is the least possible value of n that we can have here. Okay, if we were looking for the maximum possible value, what would we do in that case? We would input sine equal to 1 in that case, and that will give us the maximum value, right? So yes, using the derivative is one option, but in this case, that's much less efficient as compared to this. Is that okay? Any questions on this? Okay, so that was question number 8 from the worksheet. Any other questions? Any other questions? Okay, so Ibrahim is asking whether 0.02 inside sine would change the minimum and maximum values. Remember trigonometry? Yes, this is horizontal transformation. 0.02 multiplying here, that only changes the period of the graph, right? That only changes the period of the graph. It does not change the amplitude of the graph. That is still going to be 1. Okay, so amplitude remains 1. That does not change. 0.02 will just increase the period of the graph. That's a horizontal stretch. Okay. So yeah, if you have anything multiplying inside, the interval for sine, it remains the same from -1 to +1. Everything that you have done in paper 1, you need to know that for paper 3 as well. Paper 1 is a prerequisite for paper 3. All the P1 topics, the examiner can test them in paper 3 as well. That's the general rule. Okay. Now, some topics come directly, like you definitely need to know trigonometry, differentiation, and integration. Everything in paper 1 is tested here. But then the rest of the topics as well, you will see that the quadratics concepts will be used here, coordinate geometry, sometimes equation of circle as well. APGP, you would see like 1 or 2 functions on that, domain and range, although they will not specifically ask you to find the range of a function, but those concepts that you did in functions, how to find the least value of something, the greatest value of something. So this thing that we've done here, this is actually something that we do in functions in paper 1, in trigonometric functions, how to find the range of trigonometric functions, right? We use the extreme values of sine and cos -1 and 1. All of these concepts that you've done in paper 1, the examiner can test them in paper 3 as well. Even though they will not directly have a question on that, but some question part somewhere might require you to use those concepts from paper 1. So you do have to revise paper 1 as well. Don't spend too much time on that, but at least you should know the major concepts that you have in paper 1. So maybe spend a few hours to revise all of that. All right, let's move on to the next one. This was question number 8 from this worksheet. Let's have a look at the next one. Okay, question number 16. This one. From this worksheet or the other worksheet? For cos as well, it's the same least and greatest values, -1 and 1. For sine and cos, the least value is -1 and the greatest value is 1. Okay, but for tan, there's no limit. For tan, it goes from -infinity to +infinity. But for sine and cos, the least and greatest values are -1 and 1 respectively. Okay, all right, let's start with this one. Question number 16 from the worksheet. Okay, I would want to do a couple in which we have to form differential equations as well. We did a couple of examples last time as well, but I would want to do at least one more where we have to form a differential equation ourselves. So if you have one of those questions, let me know about that as well. Question number 16. Okay. A biologist is investigating the spread of a weed in a particular region. At time t weeks after the start of the investigation, the area covered by the weed is a meter squared. Okay, so that's one variable that we have, a, and then t weeks, that's the other variable, time and area. He claims that the rate of increase of A is proportional to this. Write down a differential equation representing the biologist's claim. That's fairly straightforward. Rate of increase of A. How do you write that? dA over dt. That is proportional to this. That equals k times square root of 2a minus 5. And that's it. That's the equation that they wanted you to write. Mostly they ask you to show a differential equation so that even if you can't do that first part, you can do the next part still. In this case, they have not given you that differential equation because it's so straightforward that they expect everyone to be able to do it. So they have not asked you to show something. Otherwise, in most questions like this, you will see that they will ask you to show a differential equation. So that leaves room for error in the sense that even if you're not able to do the first part, you will be able to do the second part still without that as well. But here, this was fairly straightforward. dA over dt, that is equal to k times this. Now, we don't have any information in the first part to find the value of k, so we just leave it like this. Now, let's look at the second part. It says at the start of the investigation, the area covered by the weed was 7 meters squared. Okay, now at the start of the investigation, what does that mean? That means when time is 0, the area covered, that's A, that is equal to 7. Okay, so that's one point that we have. At time 0, area A is equal to 7. 10 weeks later, the area covered was 27 meters square. So that's another point that we have. When t is equal to 10, remember time is being measured in weeks here. When t is 10, A is equal to 27. That's another point that we have. Assuming that the 𝗣𝗽𝗀𝗃𝗃 claim is correct, that means this equation is correct, find the area covered 20 weeks after the start of the investigation. So we want to find the value of A when t is equal to 20. At this point, we want to find the value of A. That's a 9-mark question. That's a lot of marks, but it does not look that difficult. The marks are basically because of the fact that you have to do all the thinking yourself. You have to structure the question yourself. Otherwise, what they generally do is they break the question down into multiple parts, and that makes it easier to follow, as in they structure it for you in the exam, and you have to do it one step at a time. But in this case, they want you to think about it yourself, as in what the whole process is going to be. So how do we start with this? We have this differential equation. We can start by separating the variables and solving this differential equation. Remember what we want at the end. We want A when time is equal to 20. So we want an equation in which A is the subject and it is defined in terms of t. That's what we want to do eventually. But the problem is we would have to find the value of k for that. We have this 1 point given. And we would also have to find the value of c when we get that. We have another point given. So we have 2 points given because we can use them to find the value of k and the constant of integration that we will get after integration. So it does not look that difficult. How do we approach this now? First of all, we separate the variables. How do we do that? This is 2a minus 5 square root. We can bring that to the left side because we have dA here. So we can write this as 1 over square root of 2a minus 5 times dA. dt goes to the other side and it becomes k dt. And there's no t, so we can just leave it as it is. K is a constant that can remain on the right side as well. We have separated the variables. We integrate both sides. Now, how do we integrate the left-hand side? We can use the power rule for this. We would first have to write it in the power form like this: 2a minus 5 whole raised to the power minus 1 over 2. On the right side, we have integration of k with respect to t. What's the integration of k with respect to t? It is k times t plus c. K is just a constant, right? So it's just like saying integration of 2 with respect to t. That's just 2t, right? So if it's k, that becomes kt plus c. And that's what we have on the right side. On the left side, how do you integrate this? Can we use the power rule? The expression inside the bracket is a linear expression. So yes, we can use the power rule on this. What is the integral going to be? We add 1 to the power. Minus 1 over 2 plus 1 or plus 1, that becomes 1 over 2. Divide by the new power, divide by 1 over 2. And also divide by the derivative of this thing. What's the derivative of 2a minus 5? It's 2. That's the integration on the left-hand side. 2 and 2, they get cancelled. And we're left with 2a minus 5 whole raised to the power of 1 over 2 equals kt plus c. Okay, so that's the equation that we have. Now what we can do is we can find the values of k and c. How do we find them? We have this 1 point given, t is equal to 0 and a equal to 7. Let's input that point. t0 and a7. Okay, so that's one piece of information that we have. Let's input that here. That gives us 2 into 7 minus 5 whole raised to the power of 1 over 2. On the other side, we have k times 0. That just becomes 0 plus c. So we can find the value of c from this, right? 14 minus 5 raised to the power 1 over 2, that is 3. The value of c turns out to be 3. Okay, so that's one thing that we have. Then we can find the value of k. This equation would now become 2a minus 5 whole raised to the power 1 over 2 equals kt plus 3. Now that we have the value of c, let's input the other point now. When t is equal to 10, a is equal to 27. Let's input that now. T10 and A27. Okay, what does this give us now? 2 into 27 minus 5 whole raised to the power 1 over 2. That equals 10t plus 3. No, 10k plus 3. Okay, now this is 54 minus 5, which is 49. 49 square root is 7. 7 equals 10k plus 3. Right? And the value of k turns out to be 7 minus 3 divided by 10, which is 0.4. That's the value of k that we were looking for. So what does this equation become then? The equation becomes 2a minus 5 whole raised to the power 1 over 2 equals 0.4t plus 3. That's the equation. We want the value of a when t is equal to 20. Now we can just input t equal to 20 here and see what that gives us. Put t equal to 20. Okay, we get 2a minus 5 whole raised to the power 1 over 2. That equals 0.4 into 20 plus 3. On the right side, we have 80 and 8. 8 plus 3, that's 11. 2a minus 5 whole raised to the power 1 over 2 equals 11. We square both sides, and that gives us 2a minus 5 equals 121. And the value of a turns out to be 126 over 2, which is 63. And that is what we were looking for. The value of a turns out to be 63. And that's it. That was 9 marks for some reason. Fairly straightforward. Ibrahim, did you guys get scared by looking at the number of marks? Because it wasn't really complicated. Okay. Any other questions? Any other questions? Other questions? Is A 15.5? Are you sure? Let me just verify this. The value of A is correct, right? Is there any careless error somewhere? Can somebody check this? Okay, all right. What if we find the value of k by dA over dt? What does that mean? dA over dt. Okay, so you mean from here somehow? How can you do that? We don't have any point given at which we know both a and dA over dt. So we could find the value of k if we were given some point at which we knew a and dA over dt, both of them. Then you can input that point here and here to find the value of k. But there's no information like that given in the question. So we can't do that.
So what if we put a in it, and then again another equation? We have two values of a, right?
But they are at specific points, right? A is 7 when t is equal to 0, and A is 27 when t is equal to 10.
Oh, okay.
So they're at specific points, and you cannot assume that the rate is constant, if that's what you're thinking, that you find the rate of change of these two values by maybe finding the gradient like this, 27 minus 7 over 10 minus 0, that does not work. That would be assuming that the rate of change is constant. That's a straight line. And that's not, it's clear that it's not a straight line because it's a square root function. So there's no way to find the rate of change at any particular point without additional information.
Okay, sir. Thank you.
All right, now let's have a look at another one now. So what I'll do is I will look at this recent worksheet and find a question that looks relatively difficult from this. Okay, let's try this. This is question number 9 from this worksheet. The last part does not look that difficult, but the first two parts, even though they don't carry a lot of marks, they do look a bit tricky. Okay, question number 9 from this worksheet. Okay, we'll do one in which we have to form equations after this. Let's do this one, and then we do one in which we have to form an equation, and then that's it then. If you guys don't have any specific questions, let's just do these two. We'll do this one and then one difficult where we have to form an equation. It says for the curve shown in the diagram, the normal to the curve at the point P with coordinates x, y meets the x-axis at n. So we have this point P. At this point, the normal meets the x-axis at n. The point M is the foot of the perpendicular from P to x-axis. So if you draw a perpendicular from P to the x-axis, we have this point M. The curve is such that for all values of x in this interval, the area of the triangle PMN is equal to tan x. Show that mn over y equals dy over dx. Okay, so area of this triangle, they are saying that is equal to tan x. Okay, how do we think about this now? Mn over y. Okay. So Mn is this horizontal side. What's y? Y is, okay, so the coordinates of P are x and y. We know that the coordinates of P are x and y. If the coordinates of P are x and y, what that means is, what is this perpendicular going to be? This perpendicular is going to be y, right? This perpendicular is y. Now, what does that mean? dy over dx, that's the rate of change of y with respect to x. That would be the gradient of this line. The tangent, the gradient of the tangent is this. What about the gradient of the normal? It would be negative reciprocal of that. And we can actually do this for that. This is the rate of change of that. This time, yeah, okay. So the first part, it's a bit tricky. Let me explain this to you. So you see the point P has coordinates x, y. The point P has coordinates x and y. And that means that the vertical side here is supposed to be y. Right? This side is supposed to be y. And this is mn. Can we find the gradient of Pn? Gradient of the normal. What would that be? Gradient of the normal, it's change in y over change in x, right? Let me write that here. Gradient of normal, Pn. Change in y, that's y, over change in x. However, the change in y is negative, right? So it would be negative y over mn. That's the gradient of this line. Okay, the normal that has this gradient minus y over mn. It's a negative gradient line, right? Right? This line is a negative gradient line. Change in y is y, change in x is mn. So y over mn, but we put a negative sign with that because it's a negative sloping line. What's the gradient of the tangent? Gradient of tangent at the point P. The point P is xy, right? Gradient of tangent at P. That point is xy. This is the tangent. The gradient of the tangent is the same as the gradient of the curve at that point. What's the gradient of curve? Gradient of curve is dy over dx. That's dy over dx. So we have the gradient of tangent and we have the gradient of normal. They should be negative reciprocal of each other. If we multiply them, the result should be -1. So from this, it follows that minus y over mn times dy over dx, that should equal -1, right? Because tangent and normal, they're supposed to be negative reciprocals of each other. Their gradients are supposed to be negative reciprocal of each other. Or we can say if we multiply their gradients, the result should be -1. Now, we can just take this to the other side. Minus and minus, they get cancelled. And it becomes mn over y on the other side. And that gives us dy over dx equals mn over y. That's what we wanted to prove in the first part. It required quite some thinking. But this is what you would do in this case. Okay. Gradient of normal was this. Gradient of tangent is dy over dx. You multiply them and the result should be -1. Does this make sense? Right? Yeah, fun question, sure. Won't be as much fun if it's in the exam. Okay, let's look at part B now. This was A1. Let's do A2. Okay, hence show that x and y satisfy this differential equation. Now, this differential equation has tan x here. Where is tan x being used in the question here? They're saying that the area of the triangle PMN is equal to tan x. Area of this triangle. What's the area of triangle given by? Area of triangle is half into base into height. If we take mn as the base, we can take y as the height. And we can write down the area of triangle using that. So we can say area of triangle, that is equal to half into base into height. Base of this triangle is mn, height is y. So it becomes mn times y. They have given us that the area is supposed to be tan x. So we equate this to tan x. We get tan x equal to 1/2 into mn times y. Now what we have to do is, we have to show that x and y, they satisfy this differential equation. There's no dy over dx in this, but remember what they made us prove in the first part. In the first part, they made us prove this mn over y equals dy over dx. In the form that they want, we do not want any mn. There's no mn in this equation. So we can eliminate mn from that. From this equation, What is mn equal to? It's y into dy over dx, right? If we multiply y on the other side, it becomes y into dy over dx. We can input that here, and that gives us tan x equal to 1 over 2. In place of mn, you put this y into dy over dx times y. And that's it. You've got that equation. Tan x equals 1 over 2 y squared into dy over dx. Okay, so the second part was actually simpler than the first one. That's half y squared into dy over dx equals tan x. We have proved that equation. Now they just want us to solve this differential equation to find the equation of the curve expressing y in terms of x. That's fairly straightforward. I suppose you can do that, right? What I'll do is I'll just do the integration part for you, and then you can do after that. So how do we start integration in this? We separate the variables. We can take dx to the other side, or let's first write it in the form that is written in the question by switching the left and right hand sides. This is the equation. Let's separate the variables, take dx to the right side. So it becomes 1 over 2 into y squared dy equals tan x dx. The variables are separated. This 2, it's your choice if you want to keep it on the left side or take it to the right side. It doesn't matter. You can now integrate both sides. Let's integrate the left hand side and the right hand side. What's the integration of half y squared? 1 over 2 remains as it is. Integration of y squared, add 1 to the power, divide by the new power. You can just use power rule in this. On the right side, what's the integration of tan x? How is tan integrated? Is it secant square? Derivative of tan is secant square. What's the integration of tan? Integration of tan, remember I told you have to remember the method that is used for integration of tan. You use this using the ln rule, right? This is supposed to be done using the ln rule. How exactly? You write tan as sine x over cos x. Okay, now on the left side you have y cube over 6. On the right side, what's the derivative of cos? Derivative of cos is minus sine. So we want minus sine in the numerator so that it becomes the log form. We can put a negative sign inside. To balance that, we can put a negative sign outside. And that becomes minus ln of cos of x plus c. That's the integration. You can do it after this. Input these values of x and y to find c from this. Once you have c, just make y the subject. And that's it. You can try this. This was question number 9 from the second worksheet. I'll do one more question and then we end. And that is supposed to be one in which we have to form a differential equation ourselves. Let me see if I can find one like that. In any of the two worksheets, that is relatively difficult. So 3 or 4 mark question for forming differential equation. Okay, so this looks interesting. This is question number 15 from the worksheet. Let's do this one last question and then we end for today. Okay, let's try this. All right. It says a tank containing water is in the form of a hemisphere. The axis is vertical, the lowest point is A, and the radius is R, as shown in the diagram. Okay, so we have a hemisphere here. The lowest point is A and the radius is R. the depth of water at time t is h. Okay. At time t equal to 0, the tank is full. So initially the tank is full, and time t equal to 0, the tank is full. And the depth of the water is r. Of course, when the tank is full, this is the depth of water, right? And that's the radius of the hemisphere. At this instant, a tap at A is opened and water begins to flow out at a rate proportional to square root of h. Okay, now this is the line that's telling you how to form the equation. Water begins to flow out at a rate proportional to square root of h. The tank becomes empty at time t equal to 14. That's another piece of information that we have. It becomes empty when t is equal to 14. Okay, let me write this down because this might be required later on. When time is 0, what's the height or the depth? It's equal to r, right? Depth of the water is r. And when time is 14, the tank becomes empty. If it becomes empty, what's the depth going to be in that case? That's going to be 0. So these are two pieces of information that we have that we might need to use later on. The volume of water in the tank is V. When the depth is h, it's given that V is equal to this. They've given us the volume formula for water. Show that h and t satisfy this differential equation where b is a positive constant. Okay, now how do we form this differential equation? The green highlighted part tells us how to form the equation. Water is flowing out at a rate that is proportional to square root of h. Flowing out, that's the rate of decrease of water. How is water measured? It's measured in volume. So we can write it like this: dV over dt, rate of change of volume. What's that? That's minus k times square root of h. Right? It's decreasing. It's the rate of outflow. So that will be negative. Proportional to square root of h, that means k times square root of h. That's what the equation becomes. All right. But what they want us to prove is dH over dt equal to this. How do you go from dV over dt to dH over dt? We have to use chain rule for this. What's the chain going to be like? dH over dt. That would equal product of two fractions. In the first fraction, you have dH as the numerator. In the second fraction, you have dt as the denominator. And in these places, you have the third variable. The third variable in this case is v. So we have dv here and dv here. dv over dt, we know that's minus k into square root of h. So we can input that here in place of this. What about dH over dv? This is why we have this volume formula given. So we have v equal to 1 over 3 pi into 3r8 squared minus h cubed. That's the volume formula that we're given here. What would be the v equation given in question? What do you mean by that? Okay, all right. V is equal to this, 1 over 3 pi into 3r8 squared minus h cubed. We find the derivative of this. dv, so whatever is the subject, that's what you have in the numerator, over dh. Derivative of v with respect to h. 1 over 3 pi is just a constant that will remain as it is. What about r? R is the radius of the hemisphere. That's also not a variable, that's a constant, right? R is the radius, that's a constant in this case. So we treat R as a constant as well. So 3R remains as it is. H squared, what's the derivative of h squared with respect to h? It would be 2 times h, so we have 2 times h. We multiply by the power, subtract 1 from the power. Minus h cubed, derivative of that is 3h squared. Let's simplify this. We get 1 over 3 pi into 6RH minus 3H squared. And that simplifies to 2 pi RH minus pi H squared, right? 3 gets cancelled with this and this, and you have this thing left. This is dV over dH. Now we put this thing in that chain rule and see what that gives us. dH over dV, that's reciprocal of this. So it becomes 1 over 2 pi RH minus pi H squared times dV over dt, that's minus K into square root of H. Right? That's what dH over dt turns out to be. Now we need to somehow convert it to the form that they have given. How do you go from this form to that form? In the numerator, they just have a constant. B is a constant. And in the denominator, they have h power 1 over 2, h power 3 over 2. What that means is we need to take this thing, square root of h, to the denominator. All right. Now I can write it like this first. Square root of h means it's h raised to the power 1 over 2. So I can take that to the denominator. If I take that to the denominator, it becomes, in the numerator, I have minus k. In the denominator, I can have h raised to the power minus 1 over 2. So I'm taking this to the denominator. In the numerator is power 1 over 2. When it goes to the denominator, it becomes power minus 1 over 2 times 2 pi RH minus pi h squared. Okay, now let's multiply this inside, and that would give us minus k divided by, what do they want at the end? Okay, let me just show another step. That's okay. 2 pi r. H power 1, h power minus 1 over 2. What does that become? H power 1 over 2. Minus 1 over 2 plus 1, that's 1 over 2. Minus pi into h power 2 minus 1 over 2. That becomes 3 over 2. We're almost there. So we have a form that's very similar to what they have given there. We have a constant in the numerator, and in the denominator, we have 2RH raised to power 1. They have 2RH raised to power 1 over 2. We have 2 pi RH raised to power 1 over 2. They have h power 3 over 2. We have pi h raised to power 3 over 2. What do we do next after this? What's the next thing that we should do after this? There's no pi in the denominator, right? What we can do is, we can take pi common from the denominator, so it becomes minus k over pi times 2RH raised to power 1 over 2 minus h raised to power 3 over 2. Now you see k is a constant. Pi is also a constant. So we can say k over pi is just another constant. And they have called that constant b here. That's what we can do. We can say k is a constant, pi is a constant, k over pi is just another constant. So the form that we get from this is dH over dt equals minus b over 2RH raised to power 1 over 2 minus h raised to power 3 over 2. That's what we wanted to prove in the first part. That's the equation that we have. Okay. Does this make sense to everyone? Okay. All right. Now in the second part, we just have to solve this equation and obtain an expression for t in terms of h and r. Now let's do this quickly. It's just solving this differential equation now. We have to separate the variables for that. This is the equation that we've got. Let's separate the variables. We want h terms on the left side, t terms on the right. There's no t term as such here. So we can just take h terms to the left, 2RH raised to power 1 over 2 minus h raised to power 3 over 2 times dh, that equals minus b dt. Let's integrate both sides. Variables are separated now. What's the integration of this? 2r remains as it is. You add 1 to the power. 1 over 2 plus 1, that's 3 over 2 divided by 3 over 2. minus h power 3 over 2, add 1 to the power, it becomes 5 over 2 divided by 5 over 2. On the right side, minus b is just a constant. Its integration with respect to t would be minus bt. Then you have a constant added to that. Let's simplify this. 2 goes to the numerator and it becomes 4rh raised to the power 3 over 2 divided by 3 minus 2h raised to the power 5 over 2 divided by 5 equals minus bt plus c. Okay, now what's the information that we are given? T is equal to 0 when h is equal to r. When t is equal to 0, h is equal to r. That's one point that we have. Let's input that. T0, hr. Let's input that here. T is equal to 0 and h equal to r. Okay, let's see what we get from this. 4r into r raised to the power 3 over 2 divided by 3 minus 2r raised to the power 5 over 2 divided by 5 minus equal to minus b times 0 plus c. And that will give us the value for c. We have 4r raised to the power 5 over 2, right? R raised to the power 1 and r raised to the power 3 over 2. It becomes r raised to the power 5 over 2 divided by 3 minus 2 over 5 r raised to the power 5 over 2. That equals c. And that will give us c equal to 4 over 3 minus 2 over 5. Just put that on a calculator. And that gives us 14 over 15. So C is 14 over 15 r raised to the power 5 over 2. So we found the value of C. Remember, in our final result, we want T in terms of H and R. So H and R are going to remain there. And that's okay. So C is in terms of R here. That's 14 over 15 r raised to the power 5 over 2. Let's input that here. The equation now becomes 4rh raised to the power 3 over 2 divided by 3 minus 2h raised to the power 5 over 2 divided by 5 equals minus bt plus c, which is 14 over 15 r raised to the power 5 over 2. Now we need to find the value of b somehow. For that, we have another piece of information. T is equal to 14, h is equal to 0. At t14, h is 0. Let's input that now. So now we input T14 and H0. Okay, when H becomes 0, on the left side, this term becomes 0. The second term also becomes 0. On the right side, we have minus 14 times B plus 14 over 15 R raised to the power 5 over 2. Now, what's the value of B that we get from this? 14b equals 14 over 15 r raised to the power 5 over 2. B equals 1 over 15 r raised to the power 5 over 2. Let's input the value of B here as well now. And the equation now is 4r raised to 4r h raised to the power 3 over 2 divided by 3 minus 2h raised to the power 5 over 2 divided by 5 equals minus 1 over 15 times times r raised to the power 5 over 2 times t plus 14 over 15 r raised to the power 5 over 2. That's the equation that we end up getting at the end. All right. What do we want to do next now? T in terms of H and R. So we have to make T the subject now. So we have found all the unknowns that we wanted to find, that we needed to find. All we need to do now is we need to make T the subject. Okay, and we need to find T in terms of H and R. How can we do that now? Let's make T the subject, take everything else to the other side. What I can do is I can bring this term to the left and take the other two terms to the right. So I would get 1 over 15 into r raised to the power 5 over 2 times t equals 14 over 15 r raised to the power 5 over 2, this term, plus 2h raised to the power 5 over 2 divided by 5 minus 4rh raised to the power 3 over 2 divided by 3. Now I can multiply 15 on the other side. and that will make things simpler. Fractions get eliminated. 14r raised to power 5 over 2 plus 2 into 3, that would be 6h raised to power 5 over 2 minus 4 times 5 is 20, 20rh raised to power 3 over 2, and now divide r raised to power 5 over 2 on the other side. R raised to power 5 over 2 gets cancelled in the first term, and that leaves you with 14 plus 6 h raised to power 5 over 2 divided by r raised to power 5 over 2. You can write this as a whole power as well, h over r whole raised to power 5 over 2 minus 20 r over r raised to power 5 over 2. So you have r over r raised to power 5 over 2. What does that become? In the denominator, you have r raised to power 3 over 2, right, from this. And in the numerator, you have h raised to power 3 over 2. And that's it. This is t in terms of h and r. That is what we were looking for, and that's our final answer. I missed 14. Where exactly? Okay, so no. Where did I miss 14?
Sir, it was minus 14b ना, तो b की वैल्यू तो 1/15 है, तो आप minus 14 ही डालेंगे फिर.
Where
नहीं
exactly?
ठीक है सर.
Okay.
मेरी मिस्टेक हुई.
Okay. So this is t in terms of h and r. All right. This was, you can say, above average difficulty because there was a lot of algebra involved, a lot of multiplication, division steps, which is mostly going to make students do errors at some point. You have to be very careful in this calculation so that you're not doing any plus minus errors. But apart from that, concept-wise, the first part was a bit tricky, but the second part was not that tricky. It was just a lot of simplification, and that makes you do a lot of errors. You have to be careful about that. Okay, so that's it then. If there are no questions, we end this here. And we have one topic left now, that's iteration. That's what we do on Wednesday now. We will be covering all the concepts of iteration on Wednesday, inshallah. And then on Thursday, we do practice questions on that. The worksheet, I think, is already uploaded for that as well. If you have any idea about iteration already, I would recommend that you start doing that worksheet already, so that on Thursday you know the problems that you have. We will cover the concepts on Wednesday, and then you would be expected to have done a lot of questions before the next class on Thursday, so that you know where the problems are. Even if you can't attempt a lot of questions, at least go through the questions, identify the problems that you don't understand, so that we can discuss those at least. Okay, so I have been saying this before as well. So somebody's asking, if I just do the assigned question from these worksheets, is that enough? Assigned questions from the first worksheet, and then the first 10-15 questions from the second worksheet, that is enough for topical practice, yes. Right? So while you are covering the concepts and doing topical past paper practice, for topical past paper practice, this much is enough. You do all the assigned questions from the first worksheet and the first 10-15 questions of the second worksheet. But then you have to make sure that you're doing the last 5 years of past papers alongside this. Now, of course, the time is limited now, so you want to do as much as you can. Ideally, at least last 5 years. That means 2020 onward, all components, all variants. Okay. Now, if you're able to do all of them, that's ideal. That will prepare you very well for the exams, inshallah. If not, try to go as far back as you can, starting from 2024. So you do 2024 papers, 2023, 22, and then 21 and 20. Just do as much as you can before the exams. If you have already done some practice before, some yearly practice before, you should target that at least those 5 years are done until the exams. Okay, so in our yearly past paper session as well, we will be doing the recent papers. We'll start from 2024 papers and we'll go backwards, and you'll get recordings of all the yearly past papers from 2020 onward and that as well. Okay, Saad, you're saying some people say that 8 to 10 years of past papers are must. They're not must, but yes, that will be very good practice if you are able to do that. But for that, you would have had to start just like 8 to 10 months back. Now is not the time for that, because let me do the calculation for you. So if you're saying 10 years, let me show what that means in this case. 10 years of past papers. How many papers do you have in a year? For each component, so let's say you have paper 1, you have paper 3, you have M1, and you have S1. For each component, you have 7 papers in 1 year. In 1 year, for each component, you have 7 papers. 1 in March, 3 May, June, and 3 October, November. So 7 papers for each component every year. All right. So for 1 year, that makes it 28 papers. For 10 years, that would make it only 280 papers. Okay. Now 280 papers, paper 1, let's say you can do paper 1s very quickly. Let's say 1 hour 30 minutes. You spend 1 hour 30 minutes in this. But then for paper 3, you have to keep 1 hour 50 minutes. So, okay, 1 hour 30 for this. 1 hour 50 for this. And then 1 hour 15 for this. For M1, you need that much time. For S1, you might be able to do them quicker. Let's say 1 hour. What's the average of these? 1 hour 30, 1 hour 50. Average of that is 1 hour 40. This average is 1 hour 10. And okay, so let's do a conservative estimate or an optimistic estimate that you're on average able to do 1 paper in 1 hour 20 minutes, right? Across these 4 papers. Let's take an average of 1 hour 20 minutes. That's 80 minutes per paper. 280 times 80. What do we get from that? Let's evaluate that. 280 into 80. That's only 22,400 minutes divided by 60. That's 370 hours approximately. 370 hours, right? Are you up for that? 10 years of past papers, that's not practical, okay? So don't punish yourself at this point. Even if you're able to do 5 years of past papers, that will be a lot, okay? That will be a lot. If you can do all variants for the last 5 years, even that will be very, very difficult doing it at this point. Because that would still mean like 185 hours. 185 hours in 1 day, generally, you can say you can do 2 papers at max. If you are studying maths, if you're only doing maths, maybe you can do like 3-4 papers. Even if you can do 3-4 papers in a day, that will take you around 2 months, maybe. 185 divided by 8, no, less than that. Okay, so 1 month if you can do 4 papers a day. 25 days if you can do 4 papers a day. That's not possible, right? Let's take it to 2 papers a day. That will be like 50 days, and that's pretty much the amount of time that you have left before exams. So even if you do 2 papers a day, 1 paper 1. So those of you doing composite, I'm talking about those of you who are doing composite exams. If you do 2 papers a day, paper 1 M1 and maybe paper 3 S1, any combination like this, then that will take you at least 50 days to do all of these papers for the last 5 years. Okay. If you can do that, that will be an achievement, and that should set yourself well for the exam. But yes, you can set that as a target, but then you have to do as much as possible. So for that, what you should do is start from the most recent ones, 2024, 2023, 2022. At least do these 3 years, and then go as much backwards as you can from there, and that should be good. If you can do 2 every day, that will be great, right? If you can do 2 every day, that will be great. But I'm assuming you have other papers as well, of course. If you can take out that much time, that would be very good preparation for your exam. If you can do so, you can do something like this: do one paper 1, and along with that M1 or S1 in one day, and then do one paper 3, and along with that do M1 or S1. Okay, you can try that. If you think you can pull it off, that will be great. Last 5 years, if you can do all of them, I think that should be very good preparation. All right, okay, so that's it for today. We will be doing iteration on Wednesday, inshallah. And then on Thursday, we get done with this. And on Friday, we'll have the introductory class in S1 or M1. And we start our first topic from Monday onward, inshallah. All right, let's end this for today then. I'll see you again on Wednesday. Allah Hafiz.